For a little extra practice, this problem 6.3 homework that I'm using, this is ungraded, I'm leaving this for you to review for yourself. Problem 6.3 is very much like 6.2, it's just giving us a little bit extra practice here. Omega Technology is starting production of a new supercomputer for use in large research universities. They have just completed the first unit, which took 120 man-hours to produce. Based on their experience, they estimate the learning percentage to be 80%. How many man-hours should they expect the second unit to require to manufacture? As a note, as we move from the first to the second unit for production, doubling the output, we expect the time for the second unit to be equal to the time for the first unit, multiplied by the learning percentage, 120 times 80%. So this one's going to be a little different in that Unit 1 and Unit 2 were given the time for Unit 1 here, and instead of calculating using the time, if they had given us the time it took for Unit 2, we could do a calculation, but they're telling us that the learning curve is 80%, 0.80, okay? So they are asking us how long did it take to do the second unit, and that's going to be how long it took to do the first unit times the learning curve. Okay. Now, from this, we wouldn't be able to calculate the third unit because that's not double anything that we have, but we could forecast what we should be looking at as far as 4 goes. Now, remember, what we're looking at here, we're looking at 2 units. Okay? So there's a lot of variability in real life. When you go from 1 to 2, there are those very few points of experience in this. Then when we get to 4, we have more experience. When we get to 8, we'll have more experience as we keep doubling the number there. So remember that the first 2 numbers are very low confident that the eventual learning curve would be 80%. But if it's the only data you have, you might be able to forecast how long it would take for the 4th unit. Okay, so the 4th unit would just be how long it took to do the second unit times the learning curve, and then you can do the 8th unit. Okay, you can knock yourself out doing this. Do this, you can double it. So the 8th unit should take the time it took for the 4th unit times the learning curve. Okay, so that's how it works. It's no more difficult than the other one. It's just given another piece of information. And remember, here's this lovely diagram here. I'm using this mouse so that it's not too straight. Okay, so this is the axis here. So this axis, the way that the learning curve works is as we progress, we keep increasing the number of units made. For every time we double the number of units, we experience the learning curve. So that would be between 1 and 2. It would be between 2 and 4 would be right here, and 4 and 8 would be here. And if you look at this curve, the time savings is going down. You make most of the gains right here, okay? Most of your gains are between the first and second unit, then the rest of the way down, you've taken out all the learning that you can, and it's harder and harder to find somewhere to take time out of the process till this thing flattens out ad infinitum off the edge of the page and the end of the world. So that's how that works. After a while, it just flattens out, and there's very little learning curve. And in fact, there's certain reasons that they could say that the learning curve goes the opposite, and that's at the end of a project when you are moving all your experienced people onto the next project, and you're using new hires to come in that don't have the experience, and you use that as a training mechanism for them in the world of producing things here. Okay, so you bring your new hires in on a process that's been really worked out, and that way you can train them. You know that it's them, not the process.